It's 16:54 and Pascal and Fermat are playing a simple game. Both have put £50 into a prize pot and the winner will take £100. They flip a coin. If it's heads, Pascal wins a point, and if it's tails, Fermat wins a point. The first to get to 10 points wins.
Fermat is winning by 8 points to 7 when suddenly his friend telephones him with a phone that will not be invented until the 19th century and tells him he must go, urgently. The problem is, how will they divide the prize pot fairly? Their idea was as follows. Pascal needs 3 points to win and Fermat needs 2. This means that the game will be over after a maximum of 4 rounds. There are 16 different possible outcomes and Fermat has an advantage of 1 point. Each possible outcome that leads to Pascal winning has been starred with red, and each possible outcome that leads to Fermat winning has been starred with blue. So 5 of the 16 possible outcomes lead to Pascal winning, and 11 of the 16 possible outcomes lead to Fermat winning. So they should split the prize in a ratio of 5 to 11, Pascal to Fermat. Pascal gets £31.25 and Fermat gets £68.75. This is fair as it reflects how close each player was to winning and not how many rounds they had already won.
Here is the generalisation of the problem. Let R be the number of heads that Pascal needs to win, and let S be the number of tails that Fermat needs to win. There will be a maximum of R plus S take 1 more rounds, because after that many rounds, one of the players will have definitely won.
Let's have a Pascal's triangle. We start from the top, and each time the coin is flipped, we go down left of its tails and down right of its heads. As there will be a maximum of R plus S minus 1 more rounds, when the game is finished, we'll end up in row R plus S minus 1 of the triangle. Let's now analyse row R plus S minus 1. The first number from the left can be reached if and only if all of the outcomes are tails. The second number from the left can be reached if and only if all of the outcomes are tails except for 1 heads. The third number from the left can be reached if and only if all of the outcomes are tails except for 2 heads, and so on. Therefore, if the game ends up in the first R numbers of row R plus S minus 1 from left to right, Fermat wins because the number of tails was greater than or equal to S, the number of tails Fermat needed to win. If the game ends up in the last S numbers of row R plus S minus 1 from left to right, Pascal wins because the number of heads was greater than or equal to R, the number of heads Pascal needed to win. Each number in the triangle represents the total number of possible ways to get there, going down from the top number, which is 1 in row 0. Therefore, the number of outcomes that make Fermat win is the sum of the first R numbers of row R plus S minus 1 of the triangle, because if the game ends up in those numbers of the triangle, Fermat wins. The number of outcomes that make Pascal win is the sum of the last S numbers of row R plus S minus 1 of the triangle, because if the game ends up in these numbers of the triangle, Pascal wins. The total number of possible outcomes is the sum of all of the numbers in row R plus S minus 1, which is 2 to the power of R plus S minus 1.
So the probability of winning is the number of outcomes that represents success divided by the total number of possible outcomes.
But here is the proper mathsy way of writing that. The kth number from 0 from left to right of the nth row from 0 going down in Pascal's triangle can be written as n choose k, where n choose k is n factorial over k factorial times n minus k factorial for values of k from 0 to n inclusive. This means that the probability of Pascal winning is the sum, as k goes from 0 to s minus 1, of r plus s minus 1 choose k, divided by 2 to the power of r plus s minus 1. The probability of Fermat winning is the sum, as k goes from s to r plus s minus 1, of r plus s minus 1 choose k, divided by 2 to the power of r plus s minus 1. So they should divide the prize pot in the ratio shown at the bottom of the picture, Pascal to Fermat.